20,000 people completed stool tests for their colonoscopies. Such home tests detect hidden blood in the stool. The study, published in the Annals of Internal Medicine, demonstrated that such fecal immunochemical tests, or FIT, picked up 75 to 80% of cancers. Adjusted for higher sensitivity, they may detect as many as 91% of cancers, but they have a higher rate of false positives. Colonoscopies are believed to detect 95% of colorectal tumors. Although they're not perfect, the FIT protocol can help people at average risk. They're not appropriate for people with especially high chances of developing colon cancer. Anyone who has a positive result on an FIT stool test will need colonoscopy as a follow-up.
Most people are aware that tick bites can transmit infections such as Rocky Mountain spotted fever and Lyme disease. There's another condition caused by tick bites, however. It's called alpha-gal allergy. Scientists have known for several years that the bite of a lone star tick can trigger a violent reaction to red meat. Affected individuals can develop severe symptoms hours after consuming a hamburger or pork chop. Fish and poultry don't cause the reaction. Researchers at the University of North Carolina recently reported that saliva from lone star and deer ticks can both trigger alpha-gal allergy. The ticks do not have to have fed on another animal first. This greatly increases the likelihood that someone bitten by one of these ticks will develop the allergy to red meat.
Since July of 2018, there have been more than 15 recalls of contaminated blood pressure medicines. The most recent involves the blood pressure drug Sartan, made by Hetero Laboratories and distributed by McLeod's Pharmaceuticals Limited. Both companies are headquartered in India.
The CDC estimates that at least 23,000 Americans die each year from antibiotic-resistant infections. Researchers expect this problem will only get worse in coming years. Finding new antibiotics has been challenging. Now, clinicians are turning to viruses that infect the disease-causing bacteria. This natural approach is more targeted than most antibiotics. Although bacteriophage therapy has been used in the Republic of Georgia in the former Soviet Union for many decades, it's still quite novel in the U.S. Several high-profile cases have shown that bacteriophage therapy can be effective even when antibiotics have failed. A recent review in the journal Cell, Host, and Microbe evaluates the potential therapy to combat antibiotic-resistant bacteria. Some scientists now believe that phage therapy is more than just an alternative to antibiotics. And that's the health news from the People's Pharmacy this week. Welcome to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon. When penicillin was first used to treat deadly infections like pneumonia, it was correctly perceived as one of the great breakthroughs of modern medicine. Since then, antibiotics have saved millions of lives. They're still doing so today, but bacteria have developed resistance to the most popular antibiotics, and some have developed multi-drug resistance. That means patients who contract such infections are in mortal danger.
Dr. Stephanie Stradi was faced with just such a situation when her husband slipped into a coma due to bacteria that failed to respond to any known antibiotics. What could she do? Dr. Stradi is Associate Dean of Global Health Sciences and Harold Simon Professor in the Department of Medicine at the University of California, San Diego School of Medicine. She's co-director of the UCSD Center of Innovative Phage Applications and Therapeutics and co-author of a memoir, The Perfect Predator, a scientist's race to save her husband from a deadly superbug.
We'll also hear from Dr. Saima Aslam. She cares for solid organ transplant candidates and recipients and directs UC San Diego Health Solid Organ Transplant Infectious Diseases Service.
Welcome to the People's Pharmacy, Dr. Stephanie Stradi and Dr. Saima Aslam.
Hi, it's great to be here. Thank you very much for the invitation.
Dr. Strathy, let's start with you, if you don't mind. Can you please tell us the rather extraordinary study of your husband, Dr. Tom Patterson's life-threatening drug-resistant infection? And this happened while on vacation in Egypt a few years ago.
That's right. My husband and I were on vacation, and he acquired a superbug infection. It's Acinetobacter baumannii, which is commonly referred to as Iraqibacter because so many vets come back from the Middle East with this infection. And he didn't know it at first, and neither did I. He actually had a gallstone attack, and we ended up in a clinic in Luxor, and he started to really deteriorate very quickly, and we got him medevaced out of there to Germany, and that's where they realized that he had a giant pseudocyst in his abdomen the size of a small football, and inside it was lurking this organism that a couple of days later came back as Acinetobacter baumannii, and it was almost fully resistant when they diagnosed it there, but by the time he was medevaced home to San Diego, it was resistant to every antibiotic under the sun.
How was he doing? I mean, that sounds life-threatening.
Well, he was in and out of a comatose state in the beginning, but we did manage to stabilize him. And there was a question as to whether or not they were going to operate and try to remove this cyst. But when they realized that they didn't have any antibiotics to cover it, and that he could, die of septic shock, they decided to do a procedure with interventional radiology where they poke holes in his abdomen and basically try to siphon off the fluid with catheters. And that seemed to work for a couple of weeks. But one day, in fact, it was the day before we were supposed to get out of the hospital, he sat up in bed and one of these internal drains inside him slipped, and it dumped all of that infected fluid into his abdomen, and he immediately went into septic shock right before my eyes, and rushed back to the ICU and was dying from that moment onward. It was just dreadful.
And of course, as you said, there's no antibiotic that actually can handle this infection. What did you do?
Well, my colleagues were pretty stunned when he was medevaced back to the U.S. that colistin, which is the last resort antibiotic, that this infection was already resistant to that. And when this drain slipped inside him and he became fully colonized with this bacteria, they basically said that there was nothing else that they could do.
That must have been incredibly scary.
It was just unbelievable. I remember just thinking that here I am, an infectious disease epidemiologist, and my husband is dying from what I used to consider a wimpy bacterium that I studied in undergrad days. I used to streak this bacterium on Petri dishes, and we had no, protective gear required. This is basically a bacterial kleptomaniac that has stolen all of these antibiotic resistance genes over the last couple of decades, and it's now considered to be the WHO's public enemy number one in terms of superbugs.
So without an antibiotic to overcome the infection, with your husband slipping away, you had to find some other way of dealing with this infection. What did you do?
Well, he was in a coma at this time, and I didn't even know if he could hear me, but I decided that it wasn't just up to me to decide that I wanted to kind of leave no, stone unturned. So this one particular day when his eyebrows were kind of, just twitching a little bit, I took his hand and I said, honey, I know that you've been fighting a long time and you may want to give up. And if you want to give up, that's okay. I'll let you go. But if you want to live, just, please squeeze my hand and I'll do whatever I can do to find something that will overturn this. And I waited, and 2 minutes later, he squeezed my hand really hard, and I just took it as a sign. So I went home and I did what any, scientist would do. I went and Googled it and said, multi-drug resistant bacterial infection and alternative therapies. And using PubMed, which is the Google for Scientists version, I found a couple of papers that mentioned different types of treatments that had not yet been approved by the Food and Drug Administration. And one of these was phage therapy. And I knew what bacteriophages were because I'd studied them, 30 years in my microbiology class.
Now, you said phage. Could you spell that, please?
Yes, well, phage is P-H-A-G-E, but it's short for bacteriophage. So that's B-A-C-T-E-R-I-O-P-H-A-G-E. I feel like I'm in a spelling bee.
Yeah. And Dr. Strathy, what is a bacteriophage?
Well, a bacteriophage is actually a virus that has naturally evolved to attack bacteria. So they're actually the oldest and most populous organism on the planet. In a single drop of water, there can be millions or even billions of phages, and they're everywhere. They're not just in water. They're under rocks. They're in soil. They're on our skin. They're in our bodies. And if you're trying to fight a bacterial infection that's in your gut, then the best place to find the phages that attack those bacteria are in sewage. So that's actually where we found the phages that we used to treat Tom.
Well, before we get into the specifics of how you saved your husband, I'd like to turn to Dr. Aslam and ask you, it's almost as if this is the world's way of controlling what otherwise could be an explosion of bacteria.
That is very true. And actually, there have been a number of ecological studies done which show that the amount of bacteriophages, both, within the human microbiome as well as the natural sort of geological niches, the amount of bacteriophages, outweigh actual bacteria by many fold. And so if we took into account, the viruses, bacteria, and fungi present in any landscape, the amount of viruses, which generally are bacteriophages, really outnumber the bacteria.
Well, it's so interesting because we tend to think of viruses as our enemies. Oh, yeah, they cause colds, rhinoviruses. Oh, they cause influenza. The number of viruses that are out there that make us sick scare us. And what you're saying is, whoa, wait just 1 minute. There are viruses, perhaps even in our digestive tracts, that are protecting us from bad bacteria.
Very true. And, it's not just the digestive tract, also our respiratory tract. So anywhere where we have microbiomes, and as you may know, the amount of organisms or bacteria in the human body is much more than actual human cells. And then if you add viruses to that or bacteriophages, they actually are even more than the bacteria. So it really is a fine balance.
Well, Dr. Strathy, so you looked in sewage to find a bacteriophage that would actually be capable of combating this Acinetobacter. How successful were you?
Well, it actually wasn't me that went picking through the sewage, thank God, but I did come up with the idea, so I'll take the credit for that. But I reached out to my colleague, Dr. Chip Schooley, who was then the head of our infectious disease division, and he was also a personal friend, and I said, Chip, it sounds like you guys are giving up and that there's nothing else that you can do. I've looked into some alternative treatments. What do you think of phage therapy? And he said in an email to me, what an interesting and intriguing idea, but it may be ahead of its time. But if you can find some phages that match his bacteria, I'll call the FDA and get approval for compassionate use, and we'll give it a whirl. So little did he know that it was really behind its time. Phages had been discovered 100 years ago and were being used and still are in the former Soviet Union. But I reached out to researchers all over the globe, and I found a handful that agreed to help. And one in particular at Texas A&M University agreed to be kind of the command center, where we sent him Tom's bacterial isolate, and he and his lab tested their whole library of phages and went through sewage samples to see if they could find any more that would be a precise match to the Acinetobacter baumannii infection that Tom had. We also had some help from the U.S. Navy, the Navy Medical Research Center in Frederick, Maryland, and they found some phages. So we had two cocktails that we were able to use to treat Tom, and luckily we got them in the nick of time.
You're listening to Dr. Stephanie Strathy, co-director of the UCSD Center of Innovative Phage Applications in Therapeutics. She co-authored The Perfect Predator, a scientist's race to save her husband from a deadly superbug.
You're also listening to Dr. Saima Aslam. Dr. Aslam directs UC San Diego Health's Solid Organ Transplant Infectious Diseases Service.
After the break, we'll find out how the phage therapy helped Tom Patterson recover.
What's the history of phage?
How does it work to have viruses kill bacteria?
Where do FDA and Big Pharma stand on the level of a very old treatment for dangerous infections?
We'll hear how phage therapy can be used synergistically with antibiotics to increase the likelihood of recovery.
You're listening to The People's Pharmacy with Joe and Terry Graydon.
(732-2334) or visit our website, peoplespharmacy.com. You can also download a free podcast from iTunes.
The People's Pharmacy is brought to you in part by Kaya Biotics, probiotic products made in Germany from certified organic ingredients. KAYA Biotics.com.
Today our topic is bacteriophage therapy, using viruses as a way of killing superbugs that resist antibiotic treatment.
We're talking with Dr. Stephanie Stradi, co-director of the UCSD Center of Innovative Phage Applications and Therapeutics. She's also Associate Dean of Global Health Sciences and Harold Simon Professor in the Department of Medicine at the University of California, San Diego School of Medicine. Dr. Stradi is an adjunct professor at Johns Hopkins and Simon Fraser Universities. She also co-directs the UCSD Global Health Institute and the International Core of the University Center for AIDS Research. She co-authored The Perfect Predator, a scientist's race to save her husband from a deadly superbug.
We are also talking with Dr. Saima Aslam. She is a board-certified infectious disease specialist. Her expertise is in caring for solid organ transplant candidates and recipients, as well as other immunocompromised individuals. Dr. Aslam directs UC San Diego Health's Solid Organ Transplant Infectious Diseases Service.
Dr. Stradi, you and your collaborators were able to find phages that matched up to the bacteria that were making your husband so deathly ill. How did that work in terms of helping him recover?
Well, we had two phage cocktails. One came from Texas A&M University, and one came from the Navy team. And the Texas A&M phages were ready first. And Dr. Chip Schooley and his team in the Division of Infectious Diseases here at UC San Diego put their heads together and consulted some experts. And they said, well, you know, nobody's really done this before in this kind of a way. So why don't we just administer the phages through these catheters in his abdomen that were draining off the infected fluid in his belly to see whether or not he can tolerate it. And if he lives through that, then we should go intravenous with the Navy phages because they were deemed to be more potent. And of course, I was terrified. I knew that there was a potential for Tom to die from septic shock because, again, you know, phages are sourced from sewage, and you do the best to, you know, spin off all of the debris that you can, but you don't really know how much this endotoxin, as they call it, needs to be removed. So the first day that we did this was March 15th, 2016. It's seared in my brain. And we injected these phages into the catheter in his abdomen and put a buffer solution, which is basically a salt neutralizing solution, in afterwards, because the phages need to be at a neutral pH. And then we clamped off the catheter and kept the phages in close proximity to the infection for about a half an hour, and then let that clamp go. And, the first day he seemed, to be pretty stable, but he didn't get any better, and he was still in a coma. So 2 days later, when the Navy phages arrived, and they were thought to be a much more potent, we injected those into his bloodstream. And that was one of the real innovations of my husband's case, because nobody had used phages to treat a systemic bacterial infection going the intravenous route before. And we knew how risky it was, but he was on the verge of multi-system organ failure. His lungs were failing, his heart was failing, and now his kidneys were failing too. And I was told that he was going to need to start kidney dialysis any moment. And so I signed the consent form for that, but we actually never needed the dialysis, because he woke up from his coma 2 days later, lifted his head off the pillow, and kissed his daughter's hand.
What a relief.
It was a miracle.
It really was. It really was. And when you have doctors saying this is a miracle, you believe it.
Oh my goodness, that is truly, truly amazing. Thank you so much for sharing that story. And Dr. Aslam, I wonder if you can tell us a little bit about the history of phage therapy in the Eastern Bloc.
And how do they work? This idea of having just one specific virus, one phage, to treat one bacterial infection, it's so targeted, it's so unusual.
Well, I'm happy to describe the history and also how it works. So in terms of, discovery of bacteriophages, the early discovery was initially described in a Lancet paper, I believe from 1915. And since then was actually used in the early 20th century for a variety of infectious syndromes. So there were sort of, cocktails as such for infections to treat dysentery, for example, as well as respiratory infections and pyogenic, furunculosis type infections. But in terms of it really taking off as therapy, and actually before I go there, the discovery of penicillin, around that same time, I think led to a decrease in the use of bacteriophages for these particular kind of infections in the West. During Stalin's time, there was a lot of interest in continuing to use bacteriophages, and the Eliava Institute in Georgia was set up at that time. And there are a variety of other institutes in Poland, as well as other places in Soviet Union, that continue to use bacteriophages, generally in an oral formulation, to treat similar sort of syndromes of infection. So not particularly matched initially for any specific bacteria, but for a syndrome such as dysentery or urinary tract infection, etc. In terms of how it works, bacteriophages are commonly used for a variety of applications in science. So these are very sort of small viruses in which there's a protein coat that's encoded or covers either a DNA or an RNA molecule. And it's shaped like a diamond, and there's a cylinder attached to that diamond with little fibers coming out. The fibers have specific attachment to bacteria, so it's that interaction between the bacteria and virus are very specific. And then the tail basically is a mechanism for the virus to inject its DNA or its RNA into the bacteria. Once that DNA is inside the bacterial host, it kind of hijacks the host's replication system and starts churning out multiple small viruses, which eventually can lead to killing of that bacteria, what we call lysis, and then releases thousands of viruses, in that medium, which then go on to infect other bacteria.
Dr. Aslam, the biggest problem, I suspect, in the world of infectious diseases today is antibiotic resistance. The bugs are winning the war. And once we run out of antibacterial medications, it becomes extremely difficult to treat these infections. Does resistance occur in the world of bacteriophage therapy as well, or is it just so specific that you can avoid this kind of problem?
So we're still learning about this, but unfortunately the answer is yes, resistance does occur. And we saw it occur in Tom's case, as well as other patients that we have treated at University of California in San Diego. And resistance can occur, of the bacteria to those specific viruses. At times, bacterial infections are not one specific bacteria, but maybe a few varieties of that bacteria. And so the virus may kill off, say subtype A, but then B and C will proliferate and continue the infection. So this is something we're still learning about, and in our future planned clinical trials and things, we are planning to, obtain more information and try to learn this systematically.
There's just one piece that I wanted to add here. In my husband's case, although resistance did develop and the bacteria became resistant to the initial phage, the Navy team was ready for this, and they were able to develop a second-generation phage cocktail within a couple of days, and they turned that around and sent it back to us, and that gave Tom and his bacteria the 1-2 punch. And so it's possible to actually, develop personalized phage cocktails very quickly, whereas if you have a bacteria that becomes resistant to an antibiotic and you've run out of antibiotics, it's going to be 10, 15 years or longer to develop a brand new antibiotic from scratch, where you can do with phages just right away.
Dr. Strathy, it's interesting that you mentioned the Navy, because it's my understanding that in the former Soviet Union, the Army was often sent off to war with bacteriophage kits. Is that true?
That's actually right. In fact, I know that Rommel's